19 in geometry. It is Thursday, September 4th, and today we're working on the practice quiz for Unit 3, all about quadrilaterals and polygons. And yesterday, when I was not here, you guys took notes on a video that went through the questions kind of on like the first page and the second page. So we'll make sure that we feel really good about those before we move to the rest, which is stuff that may look a little more familiar. So on the first page, you are finding the area and perimeter for each quadrilateral, and then you are identifying the type of quadrilateral, basically giving it the most specific name that you can. So I wrote down some formulas. When we're finding the area of a quadrilateral, we're taking the base times the height. When we're finding the perimeter, we are just adding all the side lengths together. So for number 1, how would I find the area? Which one's my base? Which one's my height?
Wait a minute. I thought perimeter was 2 parentheses S plus V.
That is another way to do it. I wasn't sure if I put that in that video or not. Another way to do perimeter is 2 times side length plus the base. So this is another way to do it. There's multiple ways to do perimeter. But yes, thank you for bringing that up.
I was confused.
Okay, so let's look at area. How do I find the area for number 1?
Base times the height would be 12 times 8.
Yes, so area equals 12 times 8. And what should we get?
6 inches squared.
Yes, 96 inches squared. Now make sure you're marking your units because the units, meaning inches versus inches squared, are going to make a difference. So our area is 96 inches squared. Okay. And how would I find my perimeter?
Um, 2 in parentheses 8 plus 12.
Yes, 2 times the quantity of 8 plus 12.
We give you 15 plus 24.
Yep, so we're kind of distributing there. That'll give us 16 plus 24.
That's 84 inches.
Yes, 40 inches. Good. Did anybody find the perimeter in a different way? Or did we all use that formula? Okay.
It's a rectangle.
Yes, and it is a rectangle. Good. So if you ever do forget, or maybe just don't have the perimeter formula written down, all we're doing for this perimeter, and I'm sure y'all talked about it yesterday, is we're taking both of these side lengths times 2 because there's 2 of those side lengths. You see in a rectangle, those opposite sides are equal, so I'm doing the 12 times 2. And then the other opposite sides are also equal, and that's why we're doing 8 times 2. You could always do 8 plus 12 plus 8 plus 12, but that takes a little bit longer. So that is number 1. Let's look at number 2. Number 2, how do I find the area on this one?
13.5.
13.5 is my base. My height is 11.
Gives you 148.5 inches.
Perfect. 148.5 inches squared is my area. 48.5 inches squared. And perimeter, this one might be a little trickier.
2 times in parentheses, 13.5 plus 13.5, because all your sides are the same length, so your base and your height and your sides.
Good, good. Okay, so that was what I was worried about, making sure when we're using perimeter, we're only looking at the side lengths. We're looking at the outside. So you should not use 11. Now, something else you can do to find perimeter, um, especially on shapes that have all the same side length, you could say that perimeter is that 13.5 times 4. Yes, which should give us the exact same answer.
We'll give you 54 inches.
Perfect. 54 inches.
And it's wrong.
And it is a rhombus. All of my side lengths are equal. Very good.
But there's no 90-degree angle, so it's not there.
Yes, there is no 90-degree angles right here. There's one here, but that's not one of the interior angles. That's just to show the height. So yes, this is a rhombus and not a square because I don't have 4 90-degree angles. Okay. Let's look at number 3. You've got a couple more measures being given to you in this problem. Which 2 am I going to use to find my area?
7, that's the base.
Good.
And 6.
Yes, 19.7 is my base and my height is 6. Don't use 9.3.
118.2.
Perfect. 118.2 inches squared is my area. Now perimeter.
Base, which is 19.7.
Mm-hmm.
Except you guys have and then your side length, which is 9.3.
Good. So we're taking 2 times 19.7 plus 9.3.
18.6 plus 39.4.
Yes.
58 inches.
Perfect. You'll get a perimeter of exactly 58 inches. And it is a parallelogram. Very good. Perfect, perfect. Okay. Last one on the front page. Let's look at number 4. My area is what?
16.3 times itself.
So I can do 16.3 times itself. When I multiply something by itself, we square it. So you could do this. You don't have to, though. You can also just do 16.3 times 16.3.
That gives you 265.69 inches.
Beautiful. 260. Sorry. Yes, 265. No, you're good. I think that was my fault. My hands just write things. It's not what my mind wanted. 265.69 inches squared. 265.69 inches squared. Perimeter, how do we find that?
2 in parentheses 16.3 plus 16.3. Which will give you 32.6 plus 32.6.
32.6 plus 32.6.
And that gives you 65.2 inches.
Perfect. 65.2 inches. There is another way we could find perimeter as well.
And it's square.
And it's a square. Good. All sides are equal. 4 90-degree angles. Just like the rhombus for perimeter, if you wanted to, since all 4 sides are the same, you could just do 16.3 times 4, and that would give you your perimeter as well. So lots of different options. Okay, before we go to the next page, do we have any questions about page 1? I know this is what you guys went over yesterday when I was not here, so if you want any extra practice on this or if any part of it feels a little confusing, just let me know. You guys are pretty smart, so I know you catch on pretty quickly, but don't ever be afraid to ask for help. Okay, page 2. Now we are finding area and perimeter of triangles. So I went ahead and wrote the area formula here. I have that area is 1/2 base times height. You could also think of it as area equals base times height divided by 2. That's the same thing. And then our perimeter, that's just adding up all the sides, right? So why don't we start with number 5? How would I find the area of this triangle?
Take the base, that'd be 32.8, and then times it by height, which would be 90 since it's a 90-degree angle.
You have the right idea. You have the right idea. We want to do the base times the height, but the base is going to be the bottom. So I know I labeled that S, which may have made that a bit more confusing than it needed to be. It's a side, but it's also the base. Base is always on the bottom. So we are going to use the base, which is 23.2 inches. Now, knowing that this is the base and knowing that the height has to be 90 degrees from the base, how would I find my height? Because it's actually not labeled. My height would be the exact same thing. How do you know that? Yes, the height is going to be this side right here. I know right triangles can be a little bit confusing sometimes, identifying the base and the height, but we need the height to be a 90-degree angle. Since there is a 90-degree angle, it's just going to be this other side length. And because these are both labeled S and there is one tick mark here and the opposite angles are equal, we know that these sides are equal. So this is also 23.2 inches. And so that's the base and the height. Now, does that make sense why we're using those instead? The base is always going to be the bottom on these. Okay. So what is 23.2 times 23.2?
538.
Okay, you said 538.24. Yes, we're dividing that by 2.
269.12.
Perfect. 269.12. What are my units? Inches squared. Perfect. So 269.12 inches squared. Wonderful. Okay, now just to keep my work separate, I'll use a different color for perimeter. How do I find the perimeter of a triangle? Anybody know?
3.2 plus 23.2 plus 32.
Yes. We're just going to add the three side lengths together. That's what you'll do for every one of these. 23.2 plus 23.2 plus 32.8. Add all the sides together. Let's see what that gives us.
79.2.
Perfect. 79.2. What are our units? Inches. Good. Good, good, good. 79.2 inches. Okay, so we've got our area, we've got our perimeter. What type of triangle is this? And I'm wanting to know, is it scalene, isosceles, or equilateral? This is a bonus question. It's from last unit.
You're right, isosceles.
Isosceles. Yes. So remember, isosceles, two sides are the same. And that's what we've got here. So this would be an isosceles. Isosceles. Yes.
So we don't need the other part, just the isosceles.
For this one, number 5, this wouldn't be scaling because it's got,
Well, we don't need the other part, the first part.
oh, like right isosceles. No, I'm just asking you for side lengths. You could add that on if you want, though. This is a right triangle as well, isosceles and right. But as long as you just do this, you'll get a bonus point. Okay, so let's look at number 6. For my area, I need that base and that height. What is my base for this triangle? 27. What's my height? 38 inches. And we'll divide by 2. So let's see. It is 27 times 38 should be 1,026. We'll just divide that by 2. And when somebody gets the area, let me know. 513 inches squared. Perfect. Perfect. Okay, so now for perimeter, we need to know all of our side lengths, but I'm missing a side length. What? Yeah, it's going to be the same as that other side length because they have the same label. They both have 2 tick marks, so that's also 43.5 inches. So how do I find perimeter here?
43.5 plus 43.5 plus 27.
Hmm. 43.5. 43.5 plus 27. Mm-hmm. 114 inches exactly. Good. And it is another isosceles. Now, if you wanted to take it a step further, would this be acute, right, or obtuse? Mm. Acute. Good. Yes, all of the angles are under 90 degrees. Good, good, good. Okay. Let's look at number 7. How do I find my area?
Your base and your side lengths are all the same. So
Yes.
going to be 12.2 times 10.7.
Okay, so 12.2 times 10.7. My base is 12.2 because all my sides are 12.2. Okay, and that will give us, let's see, I got 30.54 divided by 2.
Is she 65.27 inches squared?
Good. 65.27 inches squared. Okay. Find perimeter.
12.2 times 30.
Perfect. I've got 3 sides. All of them are 12.2. So let's just take 12.2 times 3.
You get 36.6 inches.
Perfect. 36.6 inches. And what type of triangle is this?
Equal.
Equilateral. Good. And if we wanted to go a step further, would it be acute, isosceles, or sorry, acute, right, or obtuse? It does? Ah, it would be acute. I know that height will throw you off. It would be acute. And that's kind of the main reason I wasn't going to ask you about naming them by angles, just because every single one has got a 90-degree angle in there, and that can be a little confusing, but that's okay. Okay, last one of the triangles. Number 8. How will I find my area? Good. 20 is my base times my height is 15. Divide by 2, which is 300 divided by 2, which is what? Good. 150 inches squared. Perfect. And perimeter.
16 plus 18 plus 20.
Good. 16 plus 18 plus 20. 54 units.
It's inches.
Inches. Perfect. 150 inches squared for area. Perimeter is 54 inches, and all 3 sides are different. So this is a scalene triangle. And just to take it a step further, acute, right, or obtuse? Mm.
We'll say obtuse.
Obtuse, let's check. Are you thinking that because of this top angle?
Yeah.
Okay, so I'm going to turn this to the side and look at it this way. It's not more than 90, is it? Because this is probably like 90. So what is it? Acute. Acute. There we go. Okay, that is our second page. Before we move on, do we have any questions about any of those? Page 3 then. Now we are to regular polygons. Now this is where you're going to want to know some of those names. You're going to find the area and perimeter for each polygon and then identify the type based off of how many sides. So it's very easy, and this is going to sound really silly to some of you. It's so easy to lose count when you're counting sides. I am going to recommend, as you count your sides to figure out what shape it is, mark it off or even write the numbers. Like for number 11, for example, I'm going to look at that one because it's got a lot of sides. I'm going to lose count. So I'm going to literally write 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be so easy to accidentally say that that has 8 sides or 10 sides. So I'd rather be safe than sorry. So let's look at number 9. And we're going to find I know I wrote area first, but really we have to find the perimeter first, don't we? Because you need the perimeter to find the area. So how do I find the perimeter of a regular polygon? N times S.
Which is number of sides plus its side.
Yes, so N means number of sides, and that S is the side length. That's what I'm writing up here at the top. So for my perimeter here, how many sides do I have?
You have 5, which makes it a pentagon.
Ah, good. 5 sides, so I know already that it's a pentagon. I can go ahead and write the type in. And then I'm going to put this in my perimeter formula. N times S. My N for my number of sides is 5. And what is my side length? 15.2. And what is our perimeter? Seventy-six. Good. That's right. 76 inches. Thank you. Okay, now for area. What is that formula?
It's perimeter times what that thing called?
Oh yeah, what's that thing called? What's the little apothem?
And the apothem is the dotted line in the middle, which is 10.5.
Yes, 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 yes. So I'm going to highlight this. Remember, guys, this perpendicular line going from the center of the shape to one of the sides, that is the apothem. Now, after we run through these problems, I actually would love to explain why that area formula works. I think it's really interesting. You might not, but I don't know. Maybe you will. Maybe you'll like it. Okay, so I'm going to use the area formula, perimeter times apothem divided by 2. So my perimeter was 76. My apothem, we just said, is 10.5. We'll divide that by 2. So let's see. 76 times 10.5.
798.
Good, 798.
Divided by 2, that's 399 inches squared.
Perfect, 399 inches squared. Perfect, perfect, perfect. Okay, that is number 9. Let's look at number 10. How many sides does number 10 have?
7, so it's a heptagon.
1, 2, 3. I'm sure you're right. I'll just double check. 4, 5, 6, 7. Good. Yes. So it is a heptagon. Perfect. Heptagon. Okay. And what should we find next?
Your side length, which is 42 inches.
Okay, my side length is 42 inches. And my number of sides, we just found is 7. So how can I use that to find perimeter?
Your sides times your height.
Yes, times 7. 42 times 7. And yes, 294. What's my units? Inches. Beautiful. Okay, now, again, how do we find area?
Perimeter times.
Mm-hmm.
Which would be 294 times 50.
Perfect. 294 times 50. Is that the whole formula?
No, you times that, you'll get 14,700, and then you divide that by 2.
Perfect. Divide by 2. Okay. And you said you got what?
14,700.
14,700. A big number.
That divided by 2 equals 7,350 inches squared.
Perfect. 7,350 inches squared. Okay. I'll leave that up for a minute in case anyone is copying these down. Now, let's look at number 11. Number 11. I already counted the sides for you. What type of polygon is this?
It's a nonagon.
A nonagon. Good. And remember, you guys don't have to memorize these names. We took notes over it a few days ago. So if you don't have the notes from the day that we talked about how to name polygons, come talk to me and I can help you because you're going to need those for your quiz. Okay, what should we find next? Perfect. I've got my N is 9, number of sides. My side length is 17.4. We can use those two measures to find perimeter. We're doing N times S, so let's do 9 times 17.4. And what will that give us?
56.6.
Perfect. 156.6 inches. And let's use that perimeter to help us find area. Now we'll also use our apothem.
It's going to be 156.6 times 25 divided by 2.
Good. 156.6 times 25 divided by 2.
And then you're going to get 3,915 and divide that by 2.
Good.
And then you get 1,957.5 inches squared.
Perfect. 1,957.5 inches squared. Oh, and something I wanted to mention for all of these, whenever you're naming the type of polygon, if you want to be just extra careful and certain that you've got the right name, or maybe you're worried about losing points, to avoid that, like I labeled that as 9 and I wrote it's a nonagon, I might also write in parentheses down here 9 sides. That way, if you accidentally miscount the number of sides and say, oh, I think this is 8 sides, and then I write octagon, but I write in parentheses 8 sides, I can at least give you some partial credit for not accidentally calling a 9-sided shape an 8-sided shape. And I can know at least you're putting the right name with the right number of sides. You just counted wrong. So if you put in parentheses the number of sides that you counted, that can help you just make sure you don't lose too much credit in case you count wrong. But it's always good to double and triple check. You never know. So I'm just going to write that on all of them. For my pentagon, I'll write in parentheses 5 sides. For my heptagon, I'll write in parentheses 7 sides. And now we'll look at number 12.
Six sides with a hexagon.
1, 2, 3, 4, 5, 6 sides. So it's a hexagon.
And your side length is 58.7, so you take that times 6.
Good. So we'll find perimeter using 6 and 58.7, and that will give us, yes, 352.2 inches.
And then you take that times your apothem, which is 44.3.
Good. So now we'll use the perimeter and the apothem to find the area. So 352.2 times 44.3 divided by 2.
Get 15,602.46.
Perfect.
Add that by 2, and you'll get 7,801.23 inches squared.
Beautiful. 7801.23 inches squared. And I know not all of us were to this point yet whenever I asked earlier, so if you need to copy these down or if you need me to move the camera back up to show number 9 and 10, just let me know. I'll leave this up for another minute or so, and I'll pause the recording for a minute. All right, so now we will look at page 4, and I want to answer a question that I just answered off camera. Somebody asked, what does this little M mean? Is that like the middle of angle A, the middle of angle B? That little M is just meaning measure of angle A. So what I'm giving you for 13 is that the measure of angle A is 120 degrees. You're going to find the measure of angle B, measure of angle C, and measure of angle D. That's all that M means. No extra steps. So for number 13, I've told you that this is a parallelogram. I've marked your sides that are equal, your angles that are equal, and I've given you some measurements. Now, the very first thing I will always recommend is to label everything that you already know on your picture. So if I am given that angle A is 120 degrees, I'm going to write 120 next to A. And that's going to help me visualize what else is 120 degrees. So using angle A, what other angle is 120 degrees? C. Yes. Those are opposite angles, and opposite angles are equal. So I'm going to write down here, measure of angle C is also 120 degrees.
Inside of that, all that equal 180 or 360.
So good question. The inside of all 4 angles equals 360. The inside angles of side-by-side angles, consecutive angles, those add up to 180 because it's half of 360. So, that being said, what angle can I solve for next? D, let's do that. So I know that A and D are consecutive angles. So A plus D equals what? 180. So it would be reasonable to solve for D by just plugging in what I have for A already. So I'm going to zoom in here. A plus D equals 180. I already know that angle A is 120. And so how would I solve for D from here?
Well, I'll subtract 120.
Good. We're going to subtract 120 from both sides, from 180. And we get D equals 60.
And B also equals.
Yes. So angle D is 60. I'll go ahead and do that. Angle D is 60 degrees. And right here, I'm going to put that on my picture, 60 degrees. And angle D is opposite to angle B, so it's also 60.
C is 42 because A is 42.
Ah, good. So we just found all of our angles, so now we're looking at side lengths. And you said B to C is 42?
And A is 42.
Yeah. So I'm going to look again at my picture. I'm given from A to D, that's right here, my short length is 42 inches. My opposite sides are equal. So BC is also 42 inches. So I've got BC is 42 inches. And I've got one length left to find. That's going to be my DC. And how do I find that?
Gives you A, which is 112.2.
Good. A to B.
B and D.
Good. A to B is 112.2. It's got 2 tick marks. Opposite sides are equal. So DC is opposite. It is equal. Also 112.2 inches. There we go. That is number 13. And we've just got one more question. One more. Number 14.
The interior of a triangle is 180.
Yes, the interior angles of a triangle do add up to 180 degrees. So that is a good thing to note. I know my 3 angles add up to 180. So that's X, Y, and Z. X plus Y plus Z equals 180. Just going to have that as a note to help me.
And you have Y, which was 30.
Okay, Y is 30.
And Z would be 90 because there's red.
Yes, Z is 90. And we know there's a special right triangle that has a 30 and a 90. What's missing? 60. There's a 45, 45, 90. There's a 30, 60, 90. If I know 90 and 30, my other angle will always be 60. So angle X is 60. Now, if you don't remember that fact, what's a way that we could solve for that missing angle, X? If I didn't remember my special right triangle. I know that angle Y is 30 because it's given. Angle Z has a box, so I know it's 90. Well, and I know that if I add all three together, it gives me 180. So couldn't I just plug those in that I do know and set an equation up to solve for x? I could. Yes. The Pythagorean theorem. Oh, that's going to be for the next part, isn't it? To find our missing side. Okay, now real quick, I forgot to write my angle Z was 90. Okay, and then so now we're moving on to our side lengths. We need to find XY. I know that XZ is 8 inches. I know that ZY is 12.5 inches. So Dustin, you go ahead and finish that for me. What equation do I set up to solve for XY?
You can do that, or you can do special triangles. So
Oh, you could do special triangles, couldn't you?
special triangles.
Okay, so tell me that way.
I thought that's what you were saying.
No, we can do it that way. Here, let's see. This was, I'll draw it 30. Oh, I'm wrong. 60, 30, 90, and so that would be x, 2x, and x radical 3. So I guess if x is right here, what is my x? Is this how you did it, Dustin? Like you set up the special right triangle?
Yep.
Okay, so what did you get?
And then that's just the 2x. If you multiply by 10, 16.
Yes. And that's actually way faster than the Pythagorean theorem. So here, I'll label it on the actual picture. I'm going to turn my page to the side. You have two options for this problem to solve for your missing side length. You could either do it the way that Dustin did it, where you know that in a 30, 60, 90 triangle, that smallest side length right here is x, and the hypotenuse is 2x. So if I know that x is 8, then 2x must be 16, because 8 times 2. So that is a wonderful way to do it. Now, in case you don't remember special right triangles, or in case you just like the Pythagorean theorem better, we can use the Pythagorean theorem to solve. So I'll show that way as well. So I know the Pythagorean theorem is a squared plus b squared equals c squared. And I need to find the hypotenuse, the longest side. So I'm solving for c. Does it matter which values I use for a and b? It doesn't. It doesn't. So I'm going to just do 8 squared plus 12.5 squared equals c squared. What would I do from here? What would I do from here?
Which is 64.
Good. 8 squared is 64. 12.5 squared is 156.25 equals c squared. Let's add those together.
220.25.
Okay, so we got 220.25 equals c squared. I hope when we square that, we get 16. I don't know. What happened?
What is it called? The checkbook thing?
Yes, square root.
There you go.
Uh-oh, I'm getting a different number. I didn't get 16 this time. What happened? Hmm. Maybe I gave you a triangle that doesn't exist. I did make this quiz a long time ago. Okay, so I got 14.8 equals C, but we just got C equals 16. What? That's an issue, isn't it? That's a pretty big issue.
Why is it an issue?
Let's see. Let me see. Mm,
Because C is supposed to be bigger than A and B.
yeah. Now let me see this real quick. If X is 8 and this is supposed to be X radical 3, let me see if 8 radical 3 is actually 12.5 because that's what it should be. Oh, it's not. I gave you the wrong number. Oh my gosh, guys. That's embarrassing. 13.8564, blah, 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 blah. That's what it should be. ZY should not be 12.5. Okay. Well, here's the deal. If on the quiz you get a different answer because of my own user error, you will not be counted wrong for it, okay? I would accept for this one because of the two mistakes I made. You could say that XY is 16 inches, but if you use the Pythagorean theorem, you'll find 14.8 inches. I will accept either answer because that is my mistake, not yours. My mistake, not yours. So really, I'm going to write this on here for the future. This cannot be 12.5. 8 radical 3 is 13.86. That's what this should be in the future. So I'll change that on future quizzes because that's crazy. That's just crazy. Okay. Okay, is there any part of this that y'all want me to go back and show? Especially on this back side, we were a little all over the place on this page. Or does everybody got what they needed? Okay, y'all. So this is the practice quiz. Your quiz looks just like it. Obviously different numbers, not all the same shapes. It will be just ever so slightly different, but as long as you feel decent about this, you're going to do great on the quiz. Now, one little thing I did want to show you that I mentioned earlier, and I know it's 10:23. Normally I give you a break by now, but I'm going to power through with you here. I'm going to show you something that will take maybe 5 minutes. Okay, so I would love for all of you to go to page 3 of this practice quiz, and I want to show you something about these regular polygons. I find it really cool, and you might too. So I want to show you why this area formula works. Okay, so let's keep in mind that the area of a triangle is base times height divided by 2. Okay, so if I had, let's see, a triangle right here, and here's my height, here's my base times height divided by 2. To find the area of a regular polygon, here's all that's happening. I'm going to try to trace this.
Just half your height.
Isn't what just half of your height? The apothem. Yeah, yeah, kind of, kind of. You're gonna see what I'm showing you here in just a second. It's kind of mind-boggling. I love it. Okay, so what if I told you that to find the area, what mathematicians discovered is that inside of a regular polygon, what we really have is a bunch of triangles. Look at this. See these triangles? So what's happening is the apothem is the height. The apothem is the height. The side length is the base. So really what we're doing is we're taking the base times the height. We're dividing by 2. Let me write that formula. Area equals perimeter times apothem divided by 2. And perimeter equals the number of sides times the side length. In this case, the side length is the same as the base, and the height is like the apothem. So what's happening here is it's really like base times height times the number of sides. That's going to tell me how many triangles I'm taking at times. So we're finding right here, the area of this triangle is that base times height, and then I'm taking it times the number 1, 2, 3, 4, 5. There's 5 triangles here. And that gives you that perimeter. I don't know. I think it's kind of cool. You see, that's exactly why we are able to find this formula. Okay, it's just breaking the shape up into a bunch of little triangles. So if I move back to this page, I can see the area of this triangle would be, let's see, my side length was 15.2 times 10.5 divided by 2. So let's see, area of that one triangle. We said 10.5 times 15.2. Oops, 10.5 times 15.2. And I got 159.6, divide that by 2. So the area of this one is 79.8. If I take that times 5, I should get 399. And I do. So the formula that I'm giving you is the cheat code, the shortcut to not having to do that and take it times 5 every single time. But it is kind of cool to break it down and see where that formula comes from. We're just breaking it up into a bunch of triangles. So I just think that's interesting. I think it's interesting. But anyway, guys, that is your practice quiz for Unit 3. So we will take the quiz. I do have it ready if any of you are wanting to take it today, up to you. However, if not, we'll just take it on Monday. You're also welcome to come in tomorrow and take it if you like, but you don't have to. This will be due, this practice quiz and the quiz will be due not Friday, not tomorrow, just because I like to give you a little bit of buffer room. I'm going to say it will be due Tuesday of next week. So that gives you the whole weekend to look over it and feel good about it. And it'll give you until next week on Tuesday to finish the actual quiz. But that is all for today. If you feel great about this, I'm going to let you go. Just show me your practice quiz before you leave. If you want to stay and want to have a little more practice on anything, or if you want to take the quiz, feel free to stay. Up to you. But I will see you guys later. That is it.